Hello. One of the things that we're going to talk about in this video, because it's important, but the systems that we're building are not big enough to be important yet, is this idea of scales of architecture and design, right? So, what we're going to do is we're going to have a look at this one here, and we're going to start that view, slideshow. We're going to talk about scales of design, right? So there's turns out that there's three kinds of ways of thinking about systems. There's the big system, which is the architecture, and then there's the interaction scale and the object scale. You've done the interaction scale and the object scale. You did that in all your four courses. If you're a direct entry student, you did all of that in your undergrad. Design patterns, UML, unit testing, integration testing, all of that stuff. What we're going to talk about today is the architectural level, just to get an understanding of how big systems are actually built and put together. So, what we should be able to do at the end of this is just talk about the three uh, different scales of design and be able to talk about the other. In particular, you should be able to talk about the architectural level and some of the examples. So, one of the things that happens quite often is that we write some code and oh, it was beautiful, and then what did I do? I can't remember it. How does it all fit together? What pieces go with what pieces, etc., etc. Um, right now, you're looking at a whole bunch of code, which is for sheet calc, right? And there is actually some design thought that was put into that. It's not perfect, as you're finding out, and a there is a design. There's an architecture to that. It's basically kind of a front end, back end. You'll see that. But anyways, let's talk about some of the bigger systems. Why do we talk about designs? It's so that we can explain things to other people, so that you can explain them to your team. When a new member joins a team, you don't just give them all the code. You give them a high level view, kind of an abstract representation of your system, such that they can understand it. What I did with the calc sheet was not really fair, but because I didn't give you any overview of the architecture, but you are learning about that, in fact. The design is more than code, it's how the things fit together. It is about the organization of the code, the relationship between the pieces of code. We have to agree on what things are, what are their names, and what they represent. So, if you think about a map, an explanation is a map of the code. Maps give you, maps are not the actual data, they're not the actual Earth, they're representations of the Earth that allow you to um, to walk around and get from point A to point B, use the roads, etc., etc. Um, the three scales of design, as I said, we're going to talk about the architectural scale. What are the objects? And so in the interaction scale, the objects are objects, and they talk to each other. At the object scale, it's like integers and variables and stuff like that. You've done all of that stuff. Um, so some of the examples that we'll talk about with architectural scale are these object-oriented layered pipeline, microkernel, or event-driven. We'll talk about those. At the interaction scale, like I always said, we have that, done that. We've done that with design patterns, and so we're going to skip over that. And at the object scale, you're talking about kind of what are the objects, how are the objects defined, right? So let's dive into the architectural scale. Um, we what are the pieces? How do they fit together? That's how what we think about it in the design. What do we learn? We talk about what do we learn at the scale. We're understanding where to go look for things. We're understanding that there's kind of a customer processing system. It allows us to look at the behavior of a system and try to go, okay, I'm trying to log in, but it doesn't work. Where do I go look for that? Well, maybe you should go and look where the login component is, and maybe there's a team that's associated with that. Maybe you can talk to the login team, and then you can go, okay, I can't log in. How does this work? So we're going to talk about some architectural styles. We've already talked about object oriented. You have objects. They encapsulate data. We will talk about layered, pipeline, microkernel, and event driven. So let's just dive into that. One of the examples that we want to talk about is the microservices at Netflix. So this is a micro architecture. So they don't have a large program that runs. They have a whole bunch of different programs. And it kind of looks like this. You have client devices, so they have some code that sits on the client devices. They have these things which are called the playback apps. These are the things that are streaming data to your client. And then you have all of this other stuff that is working in here. The OCAs are the things that send data to your device. And then here's all your backend data and your storage and stuff like that, and how Netflix stores all of its files. So what they've done is they've built their backend on these components of AWS. EC2 is elastic compute, which allows you to scale up the number of computers that are being used. S3 is the world's largest hard drive. You think of it that way. Then you have business logic, video processing, which they do. Then they have a whole bunch of queues and stuff like that, and databases, of course, right? So this is all very distributed system. A layered architecture. We think about a layered architecture. Most modern web applications are layered because, just the definition of front end and back end. We know that we have a presentation layer, then we have a back end layer, and then a persistent layer. So the business layer, the persistent layer, and the database layer are all tied together. Kind of an example of that is Amazon.com. There's a front end, and then there's a back end which uses JSON documents for all of the data. So everything you see on the screen is actually, in fact, represented as a JSON document that's rendered at the very last minute. And there's a very robust dependency on NoSQL. So what you have here is you have the presentation layer, and then you have an extensive, huge amount of business at the back that's running very fast, but all of the communication between these objects is done in JSON documents. Another way to think about this as a layered architecture is that you have these things that sit on top of each other. So at the very bottom, you always have memory, then you have device. So on a particular computer, you can have these layers where you have the hardware, process allocation, memory management, device driver, I/O management, user program, and then the operator on top of it. So that's all good to that. A pipeline architecture, if you play video games, you're watching a pipeline work. It's basically your scene is represented by a bunch of triangles. Those triangles are processed based on where the objects are, what rotations they have, where the bullets are, and then they are then transformed into objects that are in screen space, and then those are passed off to a rasterizer, which puts the colors on the screen and corresponding to the polygons that are visible, and the final part is the fragment actually does the calculation. So there's a pipeline, and the data goes from one to the other like that. How do these stages communicate? Well, you can either push data to the next one or you can pull it. In example 4, we have a plugin architecture. A lot of desktop applications behave like this. We have plugins for Visual Studio. There's actually an API for building your plugins. In 5004, we made sure that you fulfilled a standard by using the code. A thing that looked at your code and said, hey, this style is correct or not. So this GIMP, which is a painting project, allows you to build plugins that does things to your images for you. Now, when you build these plugin things, think about affordances. Affordances are things that allow you to do something. So on a door, you put a handle on the door so you can pull it shut and close it. You don't necessarily need a handle, because you can push the door and maybe put something underneath the door and pull it closed. But the handle affords you It gives you the ability to open and close the door a lot easier. So when you build something like Visual Studio Code, you build some affordances. You build ways of these plugins extending. Many examples. There's Visual Studio Code, as I said, Emacs, Lisps, Get clients. I believe Vim now has plugins. Um, Express.js, when you set up your Express server, when you look at it in the calc sheet, you'll see that there's a whole kind of methods of processing the data as it goes through. An event-driven architecture. Uber uses this very, very successfully. The basically and Amazon.com uses it as well. As I mentioned before, you have it's a layered architecture, but underneath it, there's an event-driven architecture where the communication between all of these objects is actually a JSON document that gets passed and moved around. So here, this person would say, I want to purchase a rubber duck, and in that document would be my ID, my prime status, the ID of the object that I want to buy, and then that document gets passed over here to the order placement microservice or event, and then that will trigger off an event to payment to say, hey, can one to afford a rubber duck? Does he have a credit card on hand? If so, we're going to proceed. We'll do the happy path here. Then we go to the warehouse. We say, hey, do we have any do we have a rubber duck? Yes, we do. So we go here because the payment was successful. We apply the payment. We take the money from Juancho's credit card, and then we go get that rubber duck. We tell that rubber duck to be packed up, and then we pass that off to the shipping. Again, so this is a JSON document that goes here, and so now the JSON document goes here. It says go, tells the person in the warehouse, go get the rubber duck. It's in bin number 55432. And then that shipping is put in a box and it's sent off. So there's this event driven. So Juancho wants to buy a duck. That causes an event here, and then this thing here causes an event, which is go check the credit card, go to the warehouse, see if it's there, and if all those succeed, then that goes okay. We take the money and we trigger an event to the order fulfillment, and we do the same thing with shipping. And as I just said, Amazon has a layered architecture and an event-driven architecture, so the both of them are coupled, and it works very well that way. And so we've talked about the high-level design of these systems, and then we have interaction and object. The good news of that is that you've already done that, and so we're not going to repeat that in this video. Have a great day, everyone. Thank you. Bye.